Hello, today I'm looking at M3 International A-Level January 2014. This is question 5. So we have a solid S consists of a uniform solid hemisphere of radius r and a uniform solid circular cylinder of radius r and height 3r. The circular face of the hemisphere is joined to one of the circular faces of the cylinder so that the centres of the two faces coincide. The other circular face of the cylinder has centre O. The mass per unit volume of the hemisphere is 3K, 3K, and the mass per unit volume of the cylinder is K. Show that the distance of the centre of mass of S from O is 9r over 4. Okay, so here I will begin by doing a little table of the ratio of the masses and so on. So my solid S is made of a cylinder plus hemisphere makes bullet shaped thing. So, and everything is measured from O, which is going to be down here. Okay, so first of all, to get the ratio of the masses, then I need to use the volumes and then multiply those volumes by this mass per unit volume. So for the hemisphere, I'm going to have 3K times whatever the volume is, and for the cylinder, I'm going to have K times whatever the volume is. The volume of the cylinder, then, the formula is pi r squared h. So I've got pi times the radius squared, and the radius is r, times by the height, which is 3r. For the hemisphere, I've got half of a sphere, so half of 4/3 is 2/3 pi times the radius cubed. Okay, to get the value here, I could do this plus this, but as I'm looking at the ratio here, I can divide at this point. I need to be very careful because a mistake at this stage will be disastrous, but I can simplify these. It will make the maths a lot easier if I just need to be a bit careful. So here I can see I've got pi and pi, so I can divide both of those by pi. I could divide by k, I can divide by r cubed, and here I've got a 3 divided by 3, and so here I'm left with 3, here I'm left with 2, and so here I've got 3 plus 2 makes 5. So the ratio of the masses is 3 to 2 to 5. Now I'm going to measure all the distances from O. So I need to look at this diagram a little bit carefully. So for the cylinder, the centre of mass will be halfway up the height. Well, if the height of it is 3r, it will be half of 3r. For the hemisphere, I need to measure the where the centre of mass of the hemisphere is from O. So I need to do 3r plus this little bit here. This little bit here, I can use the formula from the formula book for a hemisphere, and it is 3r over 8, 3 times the radius. Now what is the radius? The radius is r, so I can do 3r over 8 here. And then the centre of mass of the overall object will be x bar or y bar or whatever you want to call it. So now I'm ready to do moments. So I can do this times this plus this times this equals this times this. So this times this gives me 3 times 3r over 2 plus, here I've got 2 times these two things added. I'll multiply the top and bottom of this by 8 so that I've got some eighths to add. So here I've got 3 lots of 8, 24, 25 to 6, 27 equals 5x bar. Okay, so now I can just stuff all of this in my calculator to give me x bar. This is going to give me a certain amount of r's. So I will do 3 times 3 over 2 plus 2 times 27 over 8. And that gives me 45 over 4. but then it needs to be divided by 5. And so I end up with 9r over 4 as x bar. Then I'll just do a quick reality check and see if that seems like it makes sense. Well, actually it agrees with what they said, so that's very fortunate. But where would I expect the centre of mass to be? Well, a bit more than halfway up the cylinder, and halfway up the cylinder would be 1.5 r, and this is 2 and a bit more r, so actually it seems to make sense that it would be the centre of mass would be pulled kind of further up here by the weight of this. Okay, and it's pulled up quite a lot, particularly because the mass per unit volume of this was so much compared to this one. Okay, so that's your first 5 marks. Then we've got this picture which corresponds to the same shape, but now it's placed on this plane. So it says the solid S is held in equilibrium by a horizontal force of magnitude P, and the circular face of S, so that would be this, has one point in contact with a fixed rough horizontal plane and is inclined at angle alpha to the horizontal. The force acts through the highest point of the circular face of S, so there, and in the vertical plane through the axis of the cylinder as shown in figure 2. So that basically means as you look at it from here, it looks like that as you look at it from the side. The coefficient of friction between S and the plane is mu, and given that S is on the point of slipping along the plane in the same direction as P, show that mu is this thing. Okay, so here I can draw a diagram as best as I can and draw the forces on the diagram. And if they want mu, then I know I'm probably going to need the reaction force. I'm going to need to eliminate P and so on. Okay, so let's see what I can draw. So okay, so there is the surface. There is the circular face. Then horizontally I've got this force P. I've got O in the middle of there. I've got alpha here, and normally I try not to draw these kind of things at funny angles, but I don't think I can avoid it in this question. And anyway, they did most of the drawing for me. Now the centre of mass of this is going to be over here somewhere along the axis of symmetry, and they did tell me that this distance is 9r over 4, and I know this is r, this is r, and I know that the weight of this is going to act here. So here I've got mg. I know that there's going to be a reaction force straight up of capital R, and then because it said it's on the point of slipping along the plane in the direction of P, then I know friction is going to act to try to stop that motion. So friction is going to act to try and oppose the motion, and so I can call this mu r as it is on the point of slipping. There's no acceleration, so on this occasion I could use resolving, or I can use moments, or both. I've got quite a lot of unknowns here, and they didn't tell me what the mass of this was, so I've just called it this generic mass m and used the force mg. Okay, so if I resolve vertically, then I get forces up equal forces down. If I resolve horizontally, then I get forces left equal forces right. And so combining these, I can get that P is equal to mu mg. Okay, and now in order to get mu, then I would need P in terms of mg, so that the m's will cancel. So in order to get P in terms of mg, I think what I would do is take moments from this point here. And if I take moments from this point here, then it means that these two forces won't come into that formula, and I will be able to have a distance times mg, a distance times p, and then there might be some angles in there as well, and then hopefully lots of stuff will cancel out, and then I'll get what they want in the end. Okay, so let's have a look at this moments equation. So did they say what that place was called where it hits the plane? I don't think they did, so it's not called O. I'll just call this, can't call it P, let's call this M. So if I do moments about M, then if I have, this is 2r, this is alpha, so the height will be here, and this will be 2r cos alpha, sorry, sine alpha, this height, 2r sine alpha there. And so to do moments from M, I just need to go that distance times P. So I've got 2r sine alpha times by P, but P is this. Okay, so that will equal the moment of this force here. So the force is mg, and then I need to write this distance. Okay, so as I know that's 90, that's alpha, so this is 90 minus alpha. So if I draw where the vertical is, so that is alpha there. Okay, so to get this distance here, oh, this is nasty. Right, so here I've got alpha, and I know this is 9r over 4, and so if I draw in the horizontal here, it's what I want plus this little bit extra here. So this horizontal distance using this triangle is 9r over 4 times sine alpha. But as I said, that's a bit too much. I want not this little bit here. So minus, and if this is r, there I've got a z, so that is alpha. And so this little bit here, using this right angle triangle, is going to be r cos alpha. Okay, let's hope this works. So, right, I am looking for mu, so that means I need to divide both sides by mg, so that cancels. I've got r's all over the place, so they will cancel. And now I need to divide by 2 sine alpha so that I get mu on its own. So here I'm dividing, so here I've got 9 divided by 8, and I've got sine alpha divided by sine alpha, which gives me 1, minus, here I had cos alpha, which is being divided by 2 sine alpha, which gives me 1 over 2, and cos alpha divided by sine alpha makes cot alpha. So let's compare that to what they said and pray that that is correct. Oh, hooray! So they put a factor of 1/8 outside. So if I just do the same, so I've got mu is 1/8, 9 minus, and to get something equivalent to a half, I would need 4 over 8. So that'll make that 4 cot alpha as required. Okay, so that part of the question was worth 7 marks. The first part was worth 5 marks, and so there you are, there is the complete solution. As you can see, the bigger you can make this diagram, the better. This was probably a little bit too small, and it's also their diagram's a bit too small as well, because even if I draw it on there, it would still not be terribly clear to draw. Also, I think it would have been easier if the kind of less that you make alpha, because it would make this kind of more slanted and therefore easier to see the differences between these lengths that were at an angle to the horizontal, and where the horizontal is, that would have made it a little bit easier to do. Anyway, I hope you found that solution helpful. Good luck with your studies.